Hi class, in this video we're reviewing for our Unit 4 test on triangles. For the first problem, write a statement that indicates that the triangles in each pair are congruent. Okay, so for example, we could say triangle SRT is congruent to triangle, so we're going from 2 marks to 1 mark to 3 marks. So 2 marks to 1 mark to 3 marks. So XRV. Number 2, segment UW is congruent to segment HF, so that order matters. We should have put the segment hat on it. Number 3, triangle YXZ is congruent to triangle YXH, so that means that segment ZY is congruent to segment HY. For these ones, for the first one, no, there's not enough information for us to know that these two triangles are congruent because we only have 2 sides. The next one, we could mark up the reflexive side right here. So that's why we have 3 pairs of sides. So yes, these are by side, side, side. For the next problem, we can mark the vertical angles are congruent to each other. So that means that in one triangle, we have angle, side angle, and angle, side angle in the other one. So this is yes by angle, side angle. And that's the same as the next one. We could mark our vertical angles. So these 2 triangles are yes by angle, side angle. In this problem, we're looking for angle S. So marking up the diagram, we could figure out this linear pair right here. So that angle must be 6 makes 30, so 56 makes 180. So we have one angle that's 56, one that's 54. So between the 2 of them, 54 plus 56 is 110. So 180 take away 110 is 70. So that angle S is 70 degrees. Here, finding the measure of angle X, we know that these 2 angles right here are congruent to each other, so we could write that 180 take away that top vertex angle 44, we're left with 136. So 136 split evenly into 2 angles. 136 divided by 2 is 68. So that angle X is 68 degrees. Finding the measure of angle 2 here, we can mark up this diagram that all these angles have to be 60 because it's an equilateral triangle with all angles 60. So then we have the measure of angle 2 is 60 degrees. So we can write 60 equals x plus 66. So solving for x, subtract 66. And surprisingly, x equals negative 6. Figuring out what x equals here, so we can add up those 3 angles. We can say that angle x plus 59 plus 65 plus 66 adds up to 180. So therefore, x plus 190 is equal to 180. So take away 190 from both sides. And x is negative 10. In this problem, adding up all the angles, we'll have x plus 191 is equal to 180. So taking away 191 from both sides, we'll get x is equal to negative 11. In this problem, the question is if you could have a triangle with side lengths of 21, 10, and 11. So the reason why this is no is because it doesn't pass the triangle inequality theorem. If I add up the 2 smallest sides, 10 plus 11, then that's 21. And 21 is not larger than the largest side, 21. So therefore, no, you cannot create a triangle with those side lengths. In this problem, you can create a triangle with the side lengths because the two smallest sides, 2 plus 6, is 8, and 8 is larger than the largest side, 7. So yes, you could make a triangle. The second part of the question says, what kind of triangle? Is it acute, right, or obtuse? Okay, so using the Pythagorean theorem, c squared equals a squared plus b squared. So the largest side there would potentially be our hypotenuse. So if we plug that in, 7 squared is 2 squared plus 6 squared. We'll get 49 equals 4 plus 36. So you have that 49 is equal to 40. Okay, so in this problem, then this 7, this hypotenuse is too big for it to be a right triangle. So when the hypotenuse is too big, then that conclusion means that this must be an obtuse triangle. Here we're looking for the missing side x, so we could say 7 squared plus x squared is equal to 12 squared. So 49 plus x squared is equal to 144. Take away 49. And you get that x squared is equal to 96. And that's not correct. It's actually equal to 95. So square rooting both sides, we'll get x equals the square root of 95, which is approximately 9.75. This problem, finding the missing side x, you could say x squared plus 7 squared is equal to 16 squared. So that means x squared plus 49 is equal to 16 times 16, which is 256. So x squared is equal to 207. So x is the square root of 207, which is approximately 14.39. In this problem, our first goal is to mark up the diagram and find that angle 2. Okay, so marking up the diagram, it looks like we have an isosceles triangle, so the base angles are both 63. So 63 plus another 63 is 126. So 180 take away 126 is going to be 4 makes 30, so 54. That's 54. And this is a right angle here, so 90 take away 54 is going to be 36. So this missing part is 36. And here's a linear pair, so angle 2 has got to be 4 makes 40, so 144. So that means that if the measure of angle 2 is 144, and that's x plus 156, I can take away 156 from both sides. And that's why x equals 144 minus 156, so that's negative 12. Writing it nicer, x is negative 12. This problem, angles y and x are corresponding angles because they're in the same place. In this problem, angles y and x are same side, interior angles. In this problem, angles y and x are alternate interior angles. As they are here, y and x are also alternate interior angles. In this problem, the two angles that are marked are alternate exterior angles, which means that they're equal. That means we can set these parts equal. 17x minus 2 is equal to 16x plus 4. solving this equation, if I take away 16x, I'll get 1x minus 2 is 4. So adding 2, x is 6. In this problem, it appears that the two angles are congruent, but we don't know that those are both right angles. So we do know they're same side interior, so they add up to 180. We can say x plus 99 plus an 85 equals 180. So adding up 99 plus 85, x plus 184 is 180. So when I take away 184 from both sides, x is negative 4. In this problem, we're proving that angle 1 is congruent to angle 3. So we need another angle which is congruent to 1 and 3. So for instance, I could say 5. Okay, so then I'm going to start off by writing my given. So my first statement is that line M is parallel to line N, and that's given. Then I can write, I'm going to compare 1 and 3 to 5. So I'll say angle 1 is congruent to angle 5 because they're corresponding. And I'll say that angle 3 is congruent to angle 5 because they're alternate interior. So as a result, I could say that 1 is congruent to 3, is congruent to angle 3. So because this 5 repeats twice, I could substitute in the 1 for the 5, and so that's by substitution. In this problem, we're looking for both x and y, so both of these angles are congruent to each other. So that means that x plus 4 is equal to 65. If I take away 4 from both sides, x is 61. And then for y, I can say that 2y minus 2 plus another 2y minus 2 is equal to this whole length of 24. That's at this segment here is the mid-segment. The mid-segment connects two midpoints. And the mid-segment then has to be exactly half the parallel base. So if the parallel base is 24, that's why 2 of the mid-segments is equal to 24. Combining like terms, I have 4y minus 4 is 24. Adding 4y is 28. Dividing by 4, we'll have y is equal to. Good luck on your test tomorrow.